GATE 2016 Civil Engineering Set 1 Question 29. The magnitudes of vectors P, Q and R are 100 kilonewtons, 250 kilonewton and 150 kilonewton respectively as shown in the figure. The respective values of the magnitude in kilonewton and the direction of the resultant vector are. Four options have been given. The relevant NPTEL reference has been mentioned. If we are given two forces in the coordinate system, let us call this the y-axis and the x-axis. So if the one force is F1 and the second force that is given is F2, let us say the angle F1 makes from x-axis is theta1 and the angle F2 makes is theta2. So the force that are given are F1 and F2. The angle that they make from x-axis has been given theta1 and theta2. So the x component can be found. The x component of any force is given as the magnitude of the force into the angle it makes from the x-axis. So it will be F1 cos theta 1. Similarly, for the second force, its x component would be F2 cos theta 2. For the y component, we take sine of the angle as it will be 90 minus theta 2. So if we take the cos of this, it would become sine. So the y component would be F1 sine theta 1 and for F2 it would be F2 sine theta 2. If we want to find the overall x component of the resultant, it would be the sum of the two x components. It would be F1 cos theta 1 plus F2 cos theta 2. Similarly, the y component would be F1 sine theta 1 plus F2 sine theta 2. The resultant for two forces, one being Fy and another being Fx, can be found using the Pythagoras rule that would give the resultant as the square root of Fx square plus Fy square, and the angle the resultant would make from the x-axis is given by tan inverse of Fy over Fx. So using these two equations of the resultant and the resultant's angle, we can find the corresponding results for the system of forces. In this case, we have been given three forces. The first one is P, whose magnitude is 100. The second is Q, whose magnitude is 250. The third is R, whose magnitude is 150. The angles that are given are theta 1, which is 60 degrees. Theta 2 can be found. It is 60 plus 45, that would be 105 degrees. And theta 3, that would be 195 degrees, sum from the positive x-axis. So the x component would be P cos theta 1. This would be 100 into cos 60, which would turn out to be 50. The x component for Q would be Q cos theta 1, which would be 250 into cos 105. This would turn out to be minus 64.7. The third one is 150 cos 95, that is R cos theta 3. This value would be minus 144.88. The y components would be 50 root 3, 241.48 and minus 38.82 respectively for P sin theta 1, Q sin theta 2 and R sin theta 3. Adding the x components together to get the overall x component, which would turn out to be minus 159.5. Adding all the y components together, this would give the result as 289.257. So now the value of the resultant force can be found by the square root of the sum of the squares, that is fx square plus fy square. This would be minus 159.5 whole square plus 289.257 whole square. The value would turn out to be 330.32 kilonewtons. Theta here can be found as tan inverse of Fy over Fx. Here we will take both as positive for sake of simplicity. Theta would turn out to be 61.12 degrees. The thing that should be noted is fx is negative, so it is in this direction, and fy is positive, so this is in this direction. So the resultant will be somewhere here. So the theta that we find here is this theta, but the theta that we need to find is from the positive x-axis. So theta r would be 180 minus the theta that we calculated, which will be 180 minus 61.12 degrees. This would give the value as 118.87 degrees. So the respective values of the magnitude and the direction of the resultant vector are 330.4 and 118.9 degrees respectively, which is option C. The relevant NPTEL reference has been mentioned.